So the last topic I'm going to cover before we look at real games with graphics and sounds and whatnot is procedural programming. So another console application I'm going to create, session 5. So procedural programming follows on from other types of programming. So we're starting with imperative programming, where each line, each executable command is an imperative command. They tell it, let's make an integer. Let's take that integer and add on 10 to it. Or assign the value to it of 5 to start with. These are all imperative commands. That's imperative programming. And then following on from that, you have structured programming, where we put in a sort of structure that controls the flow of the program. So if I is less than 20, then do something. Otherwise, do something else. So that's structured programming. But all modern programming languages do both of those things, as well as something called procedural programming. So it's the most relevant name to what we're doing. And that procedural programming involves things called subroutines. And these come in different forms. They may be called functions, modules, routines, subroutines, methods. They've got different names, and unfortunately, it changes depending on the language mostly. You've seen one of them already. That's the main function. I'll probably use the word function a lot. They're technically supposed to be called methods in C#, but a method is just a function which is local to a program. So I'll probably use the word function a lot. It's just what I'm used to. Now in maths, you'd see functions look like this. F of x equals something, 3x plus 1, for example. We kind of borrow that terminology, f being the name of the function, x being a parameter. So in this case, main is our function, and this array of strings is the parameter. That's the command line parameter. We're not worried too much about that just now. So this has an independent variable in maths, it's called, but in programming, that is the parameter. The parameter is what you take as an input. When you provide that input, it's also called an argument. So arguments and parameters are two terms which are very, very similar and closely related, but they're not technically the same thing. The argument is what you're passing in. The parameter is what you call it when you accept it. Also, functions can return a value. So f of x equals 3x plus 1. Well, let's say we wanted f of 5. That'd be 3 times 5 plus 1. You would get 15 plus 1. You get 16. So that's your return value for the function. And some functions in programming do the same thing. This one doesn't. It's void. So it doesn't return any data, but some of them do. And if it doesn't return data, some people call it a procedure. Well, one more thing. If you can guarantee that every time you run a function, it'll give you the same result based on the same input, we call that a pure function. But games don't typically use that many pure functions because there's a lot of RNG and player input. So usually the output is very hard to predict. Okay, now in C#, as I said, they're all called methods. We start with one called the main method, but you can make your own. The key thing here is do not declare a method here. I mean, this is how you would declare a method, but you can't do it in this position. Things go all pear-shaped if you try. What's that error? Main doesn't declare a body. Well, the body's down here. We've separated the signature of the method from its body. Also, an error here, semicolon expected. Oh, we should have put a semicolon there. But then no, that's even worse. We've still separated it. So never put anything in between the curly brackets for some code and the container for the code. You put it before or after the end of another function, as long as it's inside the program. Right? Don't put it here. It doesn't like that. A namespace cannot directly contain members, such as methods. So it doesn't directly contain it. The namespace contains a program, and that program contains the methods. But that's what it looks like there. So it starts with the data type that's going to return, or if it isn't going to return anything, it says void. Please do not call your functions voids. We're not creating a void. We're creating a function which happens to have a void return type. The name of your function is called drawMap. That's its identifier. There are parentheses, round brackets, inside which we could put parameters. I'm not going to at the moment. And finally, curly brackets for your code block, which is the code that actually runs when anything calls up your draw method function. Sorry, draw map function. Now be careful when naming functions. Make sure you choose names which are meaningful. Don't call it do stuff. Just like you shouldn't name your variables foo and bar. Don't call your functions do stuff or move me or whatever. try to keep it a bit more specific than that. Use the name that describes what the function does, like handle input instead of player controls, for instance, is better. Keep it short and concise as much as possible, but don't use abbreviations unless it's very obvious what that abbreviation is. And stick to your case. And this one here is using Pascal case. Every word is capitalized. We don't typically use camel case where the first word is lowercase for methods in C#. That's not a commonly used standard. It's usually Pascal case, as I say. So inside the code block, you can put imperative commands like writeLine, like that. But that won't actually run. Putting in a method, it's going to pop up and vanish. Oh, in fact, let's put a read key in so it will pause. But it doesn't actually run that. It doesn't say you're on level 1 and then wait for a read key, because drawMap is not the function it's running. We run the main function, and there's nothing in there. It does nothing at all. If you want to make it run the drawMap code, just call up the drawMap function simply by referencing it like that. You call up the name, you use the name of the function, and then round brackets need to match the arguments to the parameters down here. But it still doesn't like that. What's the error message? An object reference is required for the non-static field or method called drawMap. The clue is in there. The method called drawMap is non-static. So let's just make it static. And bingo, let's run it now. You're on level 1. Okay, so that's calling up a method. You call a method. In fact, let's step through it. If I press F11, it starts on that first line of the main function, goes to drawMap. And what it does is it stores on the stack a bunch of data that tells it how to get back to that line once it's finished. So then it jumps into the drawMap function, does what it's supposed to do, wait for a key, blah, blah, blah. When that method finishes, it pops the data off the stack and goes back to where it came from. Carries on. So that's procedural programming in a very basic nutshell. Oh, a quick word. So the main function is static. I think I have mentioned static before, but just to make sure we're on the same page. Statics means they're created immediately upon runtime. So as soon as you hit start, everything with the word static in front of it exists already. You don't need to create a program to access drawMap because it already exists. It's static. It's already there. And if you've got one thing that's static, it cannot access something else that's static because you can't guarantee that it's there. If I made that dynamic, the reason you get that error message is because main function exists at the start of the program. drawMap doesn't, so you can't access it from there safely. Okay. Now, at this point, I'd probably diverge a little bit and look into something called top-down design. Top-down design also, it's got older names like stepwise refinement or decomposition. There's two versions, top-down and bottom-up. And top-down is where you start with a kind of big picture. You say, oh, I want to draw the map and then get input and then handle the AI or whatever, different functions that you want to create. And then you go ahead and make the functions do whatever you need to do. And you can view that as like a black box. You could create a void function here called get input and put in a bit of pseudocode in here. Pseudocode is where you structure English as if it was code. Create string for input, get input from keyboard, parse the input. So you can put different lines in here and pseudocode to try and remind you what code you still got to do. This is kind of the basic idea behind top-down programming. So here's a better example actually. Let's say we're going to make a roguelike game. I could do this separately, but I'm going to put the pseudocode in here. So, or here's a rogue-like game, not a rouge-like. It's not mascara. So in their case, there's going to be no inputs to this, no outputs from the function. I mean, outputs onto the screen, but that's a different kind of thing. So the pseudocode is going to say, let's set up the map grid, spawn the player at spawn point, and then we'll have a loop. Now loops are indented in pseudocode as well, just like they are in real code. Inside that loop, we're going to draw the map, we're going to read keyboard input, we're going to move, according to the keyboard input. And again, keep on doing all of that while the game is still in progress. So as soon as the game ends, that loop will end. So that's a bit of pseudocode. That's what we're going to turn into code. Not everybody does this. Not everybody writes pseudocode first and then turns it into actual code. Particularly more experienced programmers probably wouldn't do that very often. But it's a good thing to get used to and learn how to program with. Something that is probably more beneficial to beginners. And you can then use the top-down method. So this is the top level, and then you could take the draw map and put in some pseudocode for that, and that would be breaking it down, decomposing our pseudocode into different parts. So let's put in some more pseudocode. Oops. For each row, we are going to go through each column in the row. More haste, less speed. And while we're looking at each column in that row, if the player happens to be on this grid coordinate, then what we're going to do is draw the player. Excuse me. Otherwise, we're not drawing the player. We're going to draw whatever the map cell is for that particular location on the map. End the if statement. End the outer for loop. Sorry, the inner for loop, and then end the outer for loop. It's not always necessary to put end if and end for in, but if you've indented things properly, it should be obvious. But I just like to be sure and make it quite clear where each flow control element ends. So that's top-down design. There's also bottom-up design, and realistically, what this means is taking the lowest level items and making them first. I don't recommend it, at least not at the start. Once you have a bit more experience of games design, then you've got some idea, oh, I'm going to need a sprite class, I'm going to need a physics class, all this, whatever you need. And you'll be able to make some of the elements at the bottom first. The best idea in the long run is to use a bit of both, a bit of a top-down, a bit of bottom-up. But because bottom-up does require a bit of experience, we'll maybe leave that for later on. Something else that might be helpful is stubs. Now, stub method, let's go back to our main function. We've got draw map, which actually that's that line there. Let's say we want to then read keyboard input. That function doesn't exist yet. Now, if you hover over it, you can put in the potential fixes. One of them is generate a method. It's going to put this code in for you. And that's a stub. All that does is get rid of this error message. And in fact, it doesn't really do it even that well, because although it creates a method for you, it deliberately throws an exception which is going to crash your game anyway. Even if we take that line out, we now have a stub that doesn't do anything. And that's not necessarily a bad thing. You can use the debugger. Let's make sure we're using that namespace so we can access the debugger. You can use the debugger to write a line, just like you're writing to the screen, but instead you could say you put a line in the debugger saying that you've tried to access this function, and that's a good thing, because then you know whether it's following a certain path through your code. So that's stubs and logging at a very basic level. Let's then expand our main function. I'll take that out because I don't think I really intended to do it exactly that way. Okay, so first we want to set up the map grid. So I'm going to make that a two-dimensional array. And each row is going to have, I'm going to put O's in for walls. And put in, I'm actually going to use dots instead of spaces for the empty areas. Just to make it easier to clarify where we're going. So what's that? 1, 2, 3, 4, 5, 6, 7. Let's make it 8. There's our top wall, our bottom wall. Let's put stuff in the middle. and I'll put in a few rows in between. And then we'll just stick a few random walls in here and there to kind of populate it. Okay, so there's our map grid setup. That's that one line of pseudocode turned into actual code. Next, spawn. Spawn the player at a spawn point. We'll do that by giving him an X and a Y position. Next, the do loop. So do forever. I'm going to, while game's still in progress, but what does that mean? Well, I'm just going to have the game progress forever. So while true. While true, draw the map. That function does exist. It doesn't do anything yet, but we'll come back to that. And then we're going to handle input and update the world. So we'll get an input character from the keyboard, console.readKey. And I'm going to put true in there because the read key method, if it's got a boolean, that tells us whether it's going to intercept the key or not. And if it does intercept it, you don't see it on the keyboard, and I think that looks a bit nicer. So don't forget to change that into a character key, otherwise it will not return an ASCII code for the letter you pressed. Next, if the letter you pressed is D, and the grid coordinate to the right, because we're going to add one onto the X position that's moving right. So the grid coordinate to the right is not a wall. So in other words, if we're trying to move right and the thing to the right of us is not a wall, then we're actually going to move to the right by increasing our X position. Conversely, if you press the A key, we're going to try and move left. So that's going to take our X coordinate and subtract one. It's going to look to this cell on our left. Remember, Y and X are reversed because of just the way this structure is set up. You don't have to do it that way, but otherwise your map is going to look transposed. So look to the left, and if it's not a wall, move left. Finally, up and down, which I'm going to use W and S, and that's going to be Y pos -1, Y pos +1, instead of checking the next X position. And if it's not a wall, then we're going to change our Y position. One going down, one going up. Okay, that should let us move around, but we're not going to see anything because the draw map, all it does is say you're on level 1. So let's make it draw something, but to do that, let's get rid of this pseudocode because I'm going to code it a bit differently. There will be an input this time. To do that, I'm going to make our draw map function require a level number, just to demonstrate what parameters are like. So as soon as you do that, every call map to the draw map function requires an integer called level num, or at least it's called level num by the draw map function. It doesn't need to be given a variable with that name. You can give it level 2, level 1, level 3. So this is not a variable, it's a literal value. So there's definitely not something called level num up here, and that's absolutely fine because it's passing in a value. This is called pass by value. Like remember value types and reference types from the last video? We're passing in just a value there, not a reference to a value. More on that later. But yeah, so we'll draw map level 1. And what the draw map function is going to do is let's clear the screen first of all. And instead we're going to say you're on level followed by whatever that parameter was. And that should be pretty much all we see. Press A, S, D, W, it clears the screen, you can see it flickering. We are actually moving around, but you're not seeing it happening because all we're displaying on the screen is you're on level 1. But that's the parameter. Passing in the number 1 as a literal parameter, level num takes on the value of 1, which, you know, it could be 2 or 3 or 10 or whatever. Or you could even have a variable in there. So we could set current level to 1 and pass current level in as a parameter. It's a different variable name, and that is fine because all it does is it takes the value of current level, the 1, and passes that 1 in. Level num becomes equal to 1. and it says 1 here. So that's different from current level. It's a different variable with a different name because it's a copy of that one there. If you change the variable, it will not change the original. But again, more on that later. Okay. You know what? In fact, why not do it now? Let's say level number plus plus. We're going to advance onto the next level every time we press a key. Except it doesn't. Because let's put a breakpoint in here. Current level is 1. Hop into the function. Level number is 1. Display that on the screen. You're on level 1. And then level num, which is 1, goes up. It is level num 2. But that's level num, not current level. When you step back, current level is still 1. It's a separate variable. It doesn't record those changes. That's because it's passing the contents of that variable by value. It's passing the value in a copy of the value. If you want to pass it in by reference, you need to put the word ref there and match it with the word ref down there. So now it's passing by reference. Level num will go up and it will change the original variable as well. Okay. There's a lot more to say on that, to be honest. You can also pass reference types by value. What happens there is that the method's given a copy of the reference to the string or the array or whatever it is. If you're able to change component parts, then you can do that. But things like strings they're what's called immutable, or read-only is the same idea in C#. So you can't change individual letters in a string when you do that. You can only replace it with a whole new thing. And this causes all kinds of hassle later on, but I think that's definitely a bit more complex than I want to get into right now. Okay, so that's passed by reference in a very basic level, but you can also pass in multiple parameters. So for example, let's make a refactored version. We're going to get a level number, but we'll also have a copy of the map, please. Now the map is a two-dimensional array. Let's get the player's x coordinate and the player's y coordinate as well as input variables. Now immediately that breaks because we're not passing that data in to match it. Parameters and arguments always need to match. But nevertheless, let's fire on. We don't want to actually advance each level. So we're going to have two for loops, one for the y coordinate and one for the x coordinate. Now for the y coordinate, we're going to get the length of the array, but because it's a two-dimensional array, we need to specify which dimension we want to get the length of. So on the first dimension, dimension 0, how long is it? So that's how far does it go along the y-axis. So it's going to work out how many cells to go on the y-axis. That's the number of rows, in other words. And as you're going through each row, you also want to go through each column in the row. So that's your x coordinate. And that is going to continue until it reaches the length along the first axis. Well, the one axis. Okay, so we're now traversing along the y-axis and along the x-axis as we do so. And if the x-coordinate we're currently looking at is the player's x-coordinate, and the y-coordinate we're currently looking at is the player's y-coordinate, then we're going to display a character for the player. I'm going to use the @ symbol in roguelike tradition. Otherwise, we're going to display whatever the map coordinate is for those y and x. Sorry, whatever the map contents is for that y and x coordinates. And once we've done all of those on that line, we then want to move on to the next line. So let's just do an empty right line, take us onto the next line before it loops around onto the next y coordinate. Okay, I think that's it, is it? Let's try and see. No, build errors. What have we got? There's no argument. Oh yes, I forgot to come back and do this. So we do have the level number. We don't have the map passed in, but I mean the map is just called grid. So let's put a comma in and then the grid. You'll notice this pop up, by the way. It gives us the parameters right there. So we don't need to scroll down and see them each time. We can see that map is in bold. That's what we're currently looking at. Hit comma, player X goes in bold. So we're going to pass in X position. then the Y position, that should all match up to what we need down here. Notice, kind of important, do not put the word int in there. It already knows that x poses an integer. It said so here. It already knows that it has to be an integer that matches player x. You do not need to, and in fact you definitely shouldn't put the word integer in there. It knows that already. Okay, there's level 1. It does draw it all. There's a two-dimensional array working, and our if statement prevents us from walking into the walls. And you can reach the end there, but it doesn't really do anything. It's not really a game yet, but it sort of looks a bit like a basic game. Let's look at a couple of other tools you can get though. So there's something called a refactoring tool, which you can do in C#. So this bit here is handling the input, and I kind of put that as a separate pseudocode thing. So what I'd quite like that to be a separate function, and you can easily do that without, you don't have to cut and paste into a method of your own making. You can highlight all that code, right click, and do quick actions. The only quick action available to this particular set of code is to extract it into a method. It will give you a quick preview of how that will look. If you're happy with it, go ahead and do it. It calls it new method. Make sure you give it a better name than that. Handle input, perhaps? Now, it automatically figured out what parameters it's going to need to be able to run this code. So it's accessing the grid, the Y position, the X position. So it automatically put those in as parameters and arguments to match. It's very handy to make sure you don't miss any of those. So now we've got, oh, by the way, don't forget you can minimize these. So there's our input, our draw map, and we've kind of done all the pseudocode, so I'm going to take that out. And our actual main game code is now looking fairly slim. You could even go a bit further and say, here's our grid setup. Put that in a method if you wanted as well. What else could we do? Well, the loop, we can put in some kind of end thing. So let's make something that that's going to be a good example of how to return a value. Let's put in another function, and it's going to return a Boolean value. So this will give us a true or false. Have we reached the exit? To know whether we've reached exit, we need to know what is the current player's x and y coordinates. And if the player's x, let's say, is 5, and the player's y is, let's say, 3, then we have reached the end. So yes, we have returned true. Otherwise, we haven't reached the end, return false. So there is no way to go through that code without reaching one of these two lines. So it's always going to return something that's necessary because we've said it will return a Boolean. So now we've got a function that will give us a true or false Boolean. We could put that in here instead of that true. We could say while, so it should be while not reached exit. Don't forget that exclamation mark means not. So while we haven't reached the exit, and to do that, it needs to know what are x and y positions. So now that'll be either true or false based on your position. And when your position reaches 5, 3, it should end the game. Here we go. So that's the return values. So these are input parameters going in. That is the return value. You can have output parameters as well, but that's, again, maybe something for later on. I think I'm going to leave it there for now. Maybe do some more advanced topics later. Cheers.